a 2.4 kilogram block is dropped onto a spring, as shown in the figure, with a force constant of 3.96 times 10 to the power 3 Newton per meter from a height of 5 meters. When the block is at rest, the spring is compressed by 25 centimeters. Find the speed of the block when the compression of the spring is 15 centimeters. Okay, so let us see in detail what do we know. So first, at the initial state, the block is at rest and is at a certain elevation. The elevation of the block is 0.5 meter. Okay, and once it's released, it will go down. Okay, then the potential energy will be transformed in kinetic energy. Then, once it will hit here the plate, it will compress the spring. Okay? Now, at the final state, it will compress the spring until a state where velocity will reach zero again. So, after compression, a certain compression, the block will have a velocity of zero, and then it will start to return back. Okay? They said that when the block is at rest, so when it will stop, the compression is 25 centimeters. So at the final state, so if you want, we can say this is state zero. Okay, this is state at state zero. What do we have? We have an elevation from the plate of 0.5 meter, and we have a velocity, initial velocity v0 equal to 0. And then when the block will compress the spring and will stop at a certain level, it will stop when the compression of the spring becomes 25 centimeter. Oh, sorry, here it's height of 5 meter, not 0.5. So the height is 5 meters. And the compression of the spring is 25 centimeter. So of course here it's not to scale the figure. Okay? Figure is not to scale, and so it will compress it a certain distance of 25 centimeter, which is 0.25 meters. Now the question is, find the speed of the block when the compression of the spring is 15 centimeters.
نشتغل على الورك.
Okay, so we will apply the principle of work and energy. Okay, so in order to apply the principle of work and energy, we can do several things. We can apply between state 0 and state 2, or between state 1 and state 2. يعني both will give us accurate result. هلا هن بهيدا البروبلم كان فيهم يصعبوه شوي، كان فيهم يقولوا لنا ما يعطونا كي مثلا. اوكي، يعني هون هن عطونا information زياده عن اللزوم، لانه they could have just given the initial state, which is v0 equals 0 and a height of 5 meters, and asked us what will be the speed when the compression is 15, without telling us that the block will stop when it's compressed by 25. So here, since they gave additional information, they could have not given K, the value of the stiffness. If they don't give you the stiffness, you can find it. يعني هون يصعب البروبلم شوي, it would be a good idea to not give the stiffness. If they don't give you the stiffness, then you will have two unknowns. You will have as first unknown the speed of the block, and as the second unknown the speed, the value of K. Okay, so this is why in case we have two unknowns, we need two informations, and we need more information. But here they gave us more than the information needed. Okay, so خلينا نعملها كأنه ما عطونا K. إذا ما عطونا K, we can first apply between state 0 and state 1. Okay, this will give us the value of the spring stiffness. So let us apply here. We can apply or work and energy, or conservation of mechanical energy. Let us remind you with the two. If I want to do the principle of work and energy, what should I do? شو بيقولوا ال work and energy? We have that T1, which is the kinetic energy at state 1, plus sum of work, okay, plus sum of work from state here. We will apply from state 0 to state 1. From state 0 to state 1, so here I will call it T0, okay, equals to the kinetic energy at state 1 T1. So first, since initially my box is at rest, so it is 0, T0 is 0, plus, now, when the box will go from state 0 to state 1, what are the forces that are doing work?
عندنا التصادر الصغير
We have the tension of the spring and what?
وعندنا الويت.
Very good. We'll wait. First, خلينا
الويت
نكتب يعني هون عندنا plus work plus UW plus U of the spring, okay, equals to what is T1? What is the kinetic energy at state 1? Zero, because they said the block will stop when it is compressed, when the spring is compressed by 25 centimeters. So at state 1 here, the velocity V1 is 0.
يعني T1 0.
يعني T1 0. Okay, so here it is equal to 0. So we can deduce that the work of the weight plus the work of the spring should be 0. Now, what is the work of the weight from state 0 to state 1? It is positive or negative?
نيجاتيف.
ليه شو عم يعمل؟
لا ما هي نازلة تحت هي بوزيتيف.
البلوك نازل يعني positive work يعني plus mg times what? What is the distance the block will go down? من state 0 ل state 1 قد ايه نزل البلوك؟
5 meters.
5 نزل 5 plus 0.25 لأنه نزل 5 تيوصل على البليت رجع عمل compression للspring 0.25 meters. So in total it's mg times 5.25. Okay, this is the work of the weight. Now for the work of the spring, okay, وقتا كنا بستيت 0 كان في compression للspring شيء؟
لا يعني كانت x1 0.
مظبوط. نحن بنعرف انه الورك للسبرينج شو الديفينيشن تبعه هو
انشر دور
K.
كا x2.
مظبوط هو 0.5 K دلتا 0.5 K دلتا L at state 0 square minus مظبوط 0.5 K times delta L at state 1 square. Okay, but we know that initially can the spring unstretched يعني we can say that this is equal to m. I will replace m by its value. It's a 2.4 kilogram block يعني 2.4 times g اللي هي 10 times 5.25 minus okay minus قلنا الدلتا ال 0 هي 0 so this will cancel out لأنه initially وقت كنا البلوك كان بعيد عن السبرينج كان spring unstretched. Now at state 1 what is the stretching of the spring? It is 0.25 meters. Okay, so it is minus, so it's plus 0 minus 0.5 times K times delta L2 which is 0.25 square okay equals to 0. بهيدي equation what is the only unknown? The only unknown is K. So this will allow you إذا بتعملوا calculation بيطلع لكم value هي ذاتها تقريبا اللي هنا عطيكم إياها. Okay, so كان فيهم ما يعطونا K نحن بنجيبها from this calculation. And once we find K, how we can find the compression of the spring when the compression is 15 centimeters? How we can find the speed?
نفس الشيء بين state
نفس
1 و
الشيء.
state 2.
نفس الشيء، أو work and energy أو conservation of mechanical energy. بما إنه عملنا ال work and energy بالأول step، حنعمل هلا ال conservation of mechanical energy.
بس سؤال،
نعم.
لو ما أعطونا الكي كيف نجيبه؟
لو ما أعطونا الكي هيك بنجيبه اللي بهالإيكويشن. أنت
نفس
هون
الإيكويشن.
إيه بهالإيكويشن بتجيبه. ما أنا عم أقول لك إنه هن أعطوك information زيادة، ما في لزوم يعطوك 3 states. إذا K given بس مفروض يعطوك 2 states. هون أعطوك 2 states completely defined وأعطوك K، يعني ما لها معنى. كان فيهم ما يقولوا لك إنه when the block is at rest the spring is compressed by 25. هيدي ما بتعوزها بشيء الانفورميشن. أوكي؟ بس كيف كنت بتعوزها إذا K مش given. أوكي؟
ماشي.
Now in order to find the speed when the compression is 15 centimeter، خلينا نعمل بين state. هلا we will define new states. okay we will define state 1 مثل ما كنا قايلين انه ال compression is 0.25 ونحن state 2 the compression is 0.15. اوكي ولانه بدنا نعمل ال conservation of mechanical energy رح ناخذ reference. احسن شيء ناخذ الريفرنس هون الانيشال ستيت، يعني اذا بدكم before stretching before compression. فنحن الستيت 1 قد ايه الكمبريشن 0.25، الستيت 2 الكمبريشن is 0.15. so we can write here that this is 0.25 meter of compression for this is for state 1. And of course, we know that at this state V1 is equal to 0. And now for state 2, هيدا حنسميه هون state 2. For state 2, we have the compression of 0.15 meter. Okay, and we don't know the value of V. V2 is unknown. We want to find it. Okay, so what we will do now, we will apply the conservation of mechanical energy. شو بتقول conservation of mechanical energy؟ إنه T1 plus هون we have two types of potential energy, gravitational and elastic. So we should say plus V1 elastic plus V1 gravitational equals to T2 plus V2 elastic plus V2 gravitational. Okay, so first to start by at state 1 we know that the velocity is 0 يعني T1 is 0. Now plus what is the elastic potential energy by definition? So elastic potential energy is 0.5 times K times delta L1 square. Okay, plus for the gravitational potential home, it is positive or negative here? The gravitational potential?
Negative.
It is, yes, it is negative because I am below the datum. احنا أخذنا reference here. This is the reference line. Okay. Since I am below the reference, this means that I have a negative potential. Okay, so it is here. So here I have minus mg times h, which is here, times 0.25. Okay, equals to, and of course شو هي delta L1؟ حط مطرح delta L1 الفاليو تبعها هي 0.25. So delta L1 I can directly replace it by 0.25. And at the final state, what do I have? T2 هي اللي بدي اجيبها لانه I don't know the final velocity V2. So I will write T2 is 0.5 times mass of the block times V2 square plus what is the elastic potential? It's 0.5 K times delta L2 square. What is delta L2 at state 2?
0.15.
Exactly 0.15. So times 0.15 square. Okay. And what is the gravitational potential at this state? It is minus mg times 0.15. In this equation, I have only one unknown, which is what? Which is the velocity, v2. So I can get what is the value of v2. Okay? Any question on this problem? Okay.
بس ساعتها بصير معنا 2 ايكويشن ونحطهم ونعملها سيستم نطلع
حتى
فيه.
ما في لزوم نعمل سيستم الي،
لانه ما في
نطلع
2 unknown.
اول equation دغري بتعطيك كار. اوكي. you replace back بتاني equation بتجيب B. يعني منه سيستم صعب يعني. you can solve it in steps. اوكي.
اوكي.
Okay, another example, another problem. Two horses pull a large crate at a constant speed across a barn floor by means of two light cables. A large box of mass 250 kilograms sits on the crate. As the horses pull, the cables are parallel to the horizontal floor. The coefficient of friction between the crate and the barn floor is 0.25. What is the work done by each horse if the box is moved at a distance of 25 meters? So here, let us see the figure together. This problem I wrote the solution for you in the homework solution part 2. Okay, so this is problem 12. What do we have here? We have a crate that is entrained by two horses through cables. Okay, and on the crate, what do we have? We have a box. They gave us the mass of the box, and we have that in the first case, the cables are parallel to the floor. Okay, so the first question was, what do we want to do? We want to find what is the work done by the horses. So to know the work, you know that work is what? Is force times distance. Okay, we know the distance traveled, so we need to determine what is the value of the force. Okay, so we need to find the value of t. How to find t? They gave us a certain information. They said that the system is moving at v constant. If the velocity of the system is constant, this means what? This means that we have a zero acceleration for our system. And since acceleration is zero, we can write the equation that sum of fx is equal to zero. Okay? So here, the first step is to draw the free body diagram of the system. When we draw the free body diagram, we have the different forces are the weight of the system, the normal reaction, okay, and of course the friction. Here the type of friction is kinetic friction because you have sliding between the crate and the floor. Okay, so we did the mu k times n. Mu k is given to be equal to 0.25. So all we have to do now is to apply sum of x equals 0 in positive x direction. So we consider the positive x direction and direction of motion. And for sum of x equals 0, we have, since we have two cables, so we have 2t, okay, 2t minus the friction force, which is opposing them, equal to 0. So t equals 2 mu kn over 2. Now, in order to be able to find t, we need n, okay? So to calculate n now, we need to apply sum of y equals to 0. Along y, we have the normal and the weight of the system. So we get that n equal to w. And then once we replace n here, we can find the value of t. Okay? Now, once we have the value of t, in order to find the work, since it's a constant, if you want force, then to find the work, you just have to multiply the tension by the distance. Okay? Now, since here it's two horses, okay, so each horse will develop يعني attention T. عرفتوا كيف؟ يعني لو كان one horse with two cables كنا عملنا 2T times D. But since we have two horses and two cables, then for each, the work of each one will be equal to T times D. Okay? So this is for question A. Now for question B, they are asking what is the tension in each cable if the angle between each cable and the direction of motion of the crate is 15 degrees. Okay, so here the second question, we will repeat the same procedure, but we have a new free body diagram. So all we have to do is to draw the new free body diagram and to apply again the equations. This is the new free body diagram. Now what is different in this part is that we don't have anymore the cables parallel to floor. They are doing a certain angle with the floor. So in this case, the tension will have two components, one along X, one along Y. Okay, so here we will end up with a system of two equations with two unknowns. So first let us write in Y direction, sum of Y equal to 0. What do we have in Y? We have the weight, so it's minus W plus the normal. And don't forget the projection of the tensions on Y, which is 2T sine 15. Okay, this will give us the first equation. This equation involves two unknown, N and T. This is equation number 1. And then we write sum of X equals to 0. Along X direction, we have the projection of T, so 2T cosine 15. And we have the opposing friction, minus mu Kn equals to 0. So we end up with a system of two equations with two unknowns. So we can solve it or by the calculator. Please تدربوا على calculator how to solve system of equations. Okay? ففيكم تتأكدوا تعملوها هيدا البروبلم to make sure that you will get the true result. Okay? وفيكم تعملوها انتم بإيدكم، بس أنا I prefer تتعودوا على الكالكوليتر لأنه sometimes يكون صعب شوي السيستم. Okay? Any question on this problem? Okay, so let us continue. Problem 13. In the figure, M1 is 4 kilogram, M2 is 5 kilogram, and the coefficient of kinetic friction between the inclined plane and the 4 kilogram block is mu k equals to 0.24. Find the magnitude of the acceleration of the masses and the tension in the core. Okay. So here, this is a typical problem. Okay, we have worked on a lot of problems like this. So we can have, in order to find, you have several methods here to find the acceleration. مظبوط؟ تتذكروا فينا ناخد block 1 لحاله، block 2 لحاله to write a Newton equation for each.
كان ياخد اليو.
وفينا ياخد اليوتي. Okay? You can do whatever you want. هلا بعتقد أنا حط بالسوليوشن يمكن حاطين لكم two methods. Let me check. Yes, here in the solution, okay, you have you can do two methods. You can take the whole system, okay. هنا جود عملت الميثود انه taking the whole system، يعني نعمل along UT، نعمل projection along UT، okay. So sum FT equals MAT. هلا اكيد هون بدنا ننتبه انه if you look at the figure here، إذا ما نستعمل ال UT method، okay، عنا M2 is 5, M1 is 4. So UT will be like this, okay? So at this level, this is UT. And at this level, this is UT, okay? So M1 will accelerate up, M2 will accelerate down. So we can write, if we want to write sum of t equals MAT, so it will be sum of forces along UT equals to, since they have the same AT يعني الماgnitude أكيد okay. نحن ال tangential direction will follow velocity. يعني هون ال M1 عنده acceleration up of magnitude A وال M2 عنده acceleration down of magnitude A. So here we have they have the same acceleration since they are related by one cable okay over one pulley.
يعني M1 plus M2 by A.
No. فإذا it's M1 plus M2 times A. Now I need to project forces on UT. This is why I should put the external forces. What are the external forces? I have first the weight W2. Okay. This is along the plus UT. Here for the block, what are the forces acting on it? We have the normal reaction, but the normal reaction perpendicular to UT يعني ما بتأثر على projection along UT. We have the weight of M1. Now for the weight of M1, we need to project it on UT. It's a negative projection because it's downward. Okay. And you know that the angle here is 30 وهيدا 60 مظبوط. يعني أو بنعمل W cosine 60 to project on UT أو بنعمل W sine 30. And since it's in the negative direction يعني هون the projection is minus W1 sine 30. Okay. And of course, since you have a friction force which is downward, so it's minus F along UT, and the friction F is mu Kn. So to find F, we need to find N. And N, how we can find it?
UKM.
بس sigma Fy.
نعمل sum Fy, ناخد Y in this direction, perpendicular to the plane. Okay. So إذا سميناها هيدي Y prime, عنا along Y prime, sum of Fy prime equals to 0. So we have that plus N minus W1 cosine 30 equals to 0. Okay. So we get that N is equal to W1 sine 30. Sorry, cosine 30. Okay. And now we can write our equation. If you want to write sum of Ft, what are the forces along UT? أول شيء حدا يقول لي ليش ما حطيت التنشن forces؟
Internal.
لأنه الانترنال. أنا I considered the system. شو هو السيستم تبعي؟ This is my system. I considered the blocks with the cables with the pulleys. كله my system هيدا. Okay. So since the cable is internal to the system, then the tension is not considered as an external force. So when I do sum Ft, I have for M2, I have only plus W2, while for M1, I have minus W1 sine 30 and minus the friction. So sum Ft equals to plus W2 minus W1 sine 30 minus the friction. And what is the friction? I can replace the friction by mu k times n. And what is n? N is W1 cosine 30. Okay, this is equal to M1 plus M2 times A. And in this way, I can find the value of A. Okay, now they asked also for the tension in the core. How can I find the tension now? What should I do to find the tension?
Sum of forces along Y.
إيه بس باخد أي system؟ فيني اخد كل السيستم وجيب التنشن شيء؟
باخذ الماس وحدة
system واحد.
ماس من
لا،
الشغل
بدي اخذ
الأساسي.
mass وحده. So I can to find the tension now I can take or M2 or M1. مين أهين؟ M2 أكيد. M2 is easier لأنه M2 بس عليها الويت والtension.
والتنشن.
Okay, so now I can take M2 and say that for M2, since I know now the acceleration, I can calculate T. I can calculate it by simply saying that sum of forces along كمان UT. Okay, بعدنا عارفين بعدنا أعمل sum of forces sum of T equals MAT. بس لأنه أخذ system M2 لحالها يعني بس equal to M2 times A. Now, what are the forces along UT on the block M2 only? It is plus W2 minus T. So plus W2 minus tension equals to M2 times A. So I get, and already I have calculated A, so T is equal to, you know that the weight هو M times G. Okay, so T is equal to M2G minus M2A. يعني M2 times G minus A. Okay, and also of course I could found T from M1. اثنيناتهم بيعطوني the same result, because if I take M1, what are the forces for M1? I have the tension T and I have the friction F and I have the projection of the weight. يعني هول كلهم بدنا نحطهم إذا أخذنا M1. Okay, so إذا أخذنا M1 بدنا ناخد T و F وال projection of weight. Okay, so let us write the equation for M1.
بس مش أحسن لو بلشنا
انتوا بتعملوا وحده من
ناخد
الاثنين.
كل ماس.
هلا هون الي لانه طلبوا التنشن منكم يمكن احيانا لكم تاخذوا التو ماسز. اوكي، بس حتى ليك شو هينه اذا بتاخذ M2 بس كمان كثير هينه، يعني ما بتضطر ساعتها تعمل لها M1. يعني هون بما
أنا
انه
لسه قصدي من الأساس
ايه لانه
ما ناخد
طلبوا
UT.
التنشن معك حق، يمكن فينا من الاساس ناخذ اثنين، بيطلع لنا 2 equations 2 unknowns كمان بتزبط. So انتوا you have several possibilities. انا بعلمكم كل الميثودز وانتوا نقوا اللي بتناسبكم. بس اذا ما طلبوا التنشن احيانا نعمل اكيد اول ميثود. اوكي
أوكي، أول ميثود شو بتطلع لنا هي بالإجمال؟ شو أكثر شيء
الاكسلريشن.
بتساعدنا؟
الاكسلريشن من دون ما تجيب
Acceleration.
التنشن بتخليك تجيب الاكسلريشن without calculating the tension، لانه بتكون الكيبل internal to the system. اوكي، بينما اذا بتاخذ كل بلوك لحال، يعني هون اذا بتاخذ البلوك 1 لحال شو الايكويشن له؟ بيكون فيها T وبيكون فيها A. اوكي، يعني on if I take M1 sum of T عليه on M1 sum of T on M1 بيعطيني equal to M1 times A equals to if you project the forces عندك plus T عندك minus الفريكشن عندك minus W1 sin 30. Okay, so here already you have calculated the acceleration and you know the friction, so you can calculate the value of T. So T is equal to M1A plus the friction اللي هي mu K times N اللي هي W1 cosine 30 plus W1 sin 30. Okay, بس بهالطريقة ما بتضطر تعمل two equations with two unknowns. لو أنت أخذ M1 M2 كل وحدة لحالها بيطلع لك two equations with two unknowns اللي هن T و A.
بتطلع من السيستم.
بتطلع. اوكي.
عندي سؤال.
نعم.
بس مش عن هذا الاكسرسايز بالثانية مش ال1 هن في 1 و 2 ما هيك؟
نعم.
بال2 اكسرسايز 1 كان في ضنيه ناقصه؟
وين؟ لا ما كان في ضنيه ناقصه. وين؟
ها انه x of t equals 3 plus 4t plus ct square minus 2t cube.
هيدا نمبر. اي نمبر عم تحكي عنه انت؟ نمبر
1
1
1
يعني
exercise 1
exercise 1 لا ما
Yes.
كان انا ما عندي يا ناقص، ما بعرف انتوا ليش قلتوا لي ناقص. انا
اوكي
اصلا انا
لانه
رجعنا حليناه انا وياكم بالصف، بس انا بالسوليوشن ما انتبهت انه عطينا اكس، فكرت انه عطينا اي، فكرتها اكسلريشن، بس صلحت لكم اياها بالصف، قلت لكم تجيبوا الاكسلريشن بدكم تعملوا derivation 2 times لهي الايكويشن بيطلع لكم
ايه نحن
A.
هيدي مش مبينه عنا.
بسيطة، حليناه مرة الماضي انا وياكم.
بس لان
أوكي.
انا يمكن ما كنت بالصف. هل ام اوفر اس شو وضعها؟
هيدي ماشي هاليونت متر بير سكند. اوكي. مش
اوكي
انت هون
اوكي
x of t x of t is in meter.
يس
فوقت عندك 3 it's a constant without unit، يعني بتكون 3 no unit. بينما وقت تضرب هون مثلا تضرب ب t، اوكي، يعني انت عندك 4t اجباري تيطلع لك x in meter، ال4 لازم تكون شو؟ meter per second.
متر بير سكند.
وهون c شو لازم تكون اليونت تبعها؟ لانه عندك t square. اوكي.
متر
لا،
متر بير سكند.
meter per second square. اوكي. وهون
اوكي اوكي
هيدي 2 meter per second cube. اوكي. هيدا بس
اوكي
هيدي يعني اليونت بس ماشي،
بس عم بسأل لانه انا ما كنت على الكوركشن وانه منا مبينه عندي فعم
يعني ما
بتاكد.
بيأثر. اوكي.
اوكي
بس
ميرسي.
انا بالسوليوشن بالسوليوشن اللي بعثت لكم اياها قلت لكم انتبهوا، انا كنت محطتها A هي X، يعني تجيبوا A شو بتعمل derivation 2 times لهيدي
ديريفاتيف.
الايكويشن. The first time شو بتعطيك 4
في بترجع
بلس
بتعطيني اي
مظبوط بتعطيك V plus 2CT minus 6T square.
6 تي
اوكي.
سكوير.
وبترجع بتعمل ديريفي مرة ثانية بيطلع لك الاكسلريشن equation.
اوكي
وكثير هين
أوكي.
السؤال بتطبقها على 3 seconds، ما انت بتعرف انه sum of forces equal MA. اوكي. هن عاطينك انه at t equals 3 seconds عاطينك الفورس equal to 36 نيوتن.
هيك
فبتجيب
عرفت.
it's very simple، يعني ما بده شيء السؤال.
يس
اوكي.
اوكي ثانك.
حدا بعد عنده question على البروبلم اللي عملناه قبل ما نبلش بواحد ثاني؟ اوكي. اصلا رح تخلص السيشن I will open a new one. اوكي. Yeah.